This meeting is being recorded.
So I'm creating this video to help you with some of the lab steps for our limiting reactants lab. I'm going to start by putting on my safety goggles, and I'll show you some of the equipment that we have here. For this lab, you'll need a scale for measuring your reactants, and the two reactants will be baking soda or sodium bicarbonate, as well as citric acid, which you can see here. I will give you these ingredients in smaller containers, more similar to this one. That way, if something happens to the reactant, we don't waste the whole bottle of the substance. You will also need a test tube in which you'll perform the experiment. And you want a test tube that is dry if possible. This one has just like 1 or 2 drops of water in it, so I'm going to tap it out. If the test tube is wet, you could also wrap a paper towel around a pencil to dry it before you start, because water will get the reaction going, and we want to wait until we're ready to measure the products before we allow the reactants to properly combine. So I'm going to place this here, and I'll just move these over so you can see a little bit better. I'm going to do the first combination of reactants that you can see in the data table. And then you will repeat that as well as do the other combinations. So trial 1 calls for 0.1 grams of baking soda. I'm going to use this medicine cup. I'm going to zero the scale. And I'm going to measure 0.1 grams. Because these are very small amounts, I'm going to hold my scapula over the medicine cup, and I'm just going to tap it gently rather than dumping it all at once. We're up to 0.04. 0.06, and 0.10. So that's perfect. Instead of using a funnel, I think you'll be able to just pinch the medicine cup and pour the ingredient into the tube. Make sure that you get it all, because we're using very small quantities and this is a quantitative lab. Next, I'm going to measure 0.2 of my citric acid because that's what it calls for. Use the same method that I used for the baking soda. So I'm going to place it over the cup. I'm just going to tap the edge of the scapula to dump a little bit at a time into the cup. We're at 0.12, 0.14, 0.15, 0.21. That would be fine. As long as you're close, I would say 0.20, 0.21, 0.22 is fine. If you're going for 0.1, then it's okay to be a little bit above or below, but you want to make sure that if you rounded, you would still get that number. The closer, the better, because these are very small quantities. So we have 0.2 grams of citric acid. I'm going to add that to the tube. Again, being careful not to spill any. And then to combine those two ingredients, they're not going to react since they're both dry. But to combine them, I'm just going to hold the tube on a slant. I'm just going to gently flick the bottom. If you're worried that you're going to spill it, you could put the cap on first. There should be a purple cap available. Or if you have a white plastic test tube, you might have a white cap available. But I'm just going to be careful as I combine those two ingredients. Then I need to put the black rubber stopper in the top. You'll notice that it has a little hole in it, and that's for adding the water. I'm not going to push too hard, but I'm going to try to get a good seal there. I have a syringe that has a little attachment to make it smaller. So I'm just going to start with the syringe empty, place it in the water, and I'm going to fill it to 5 milliliters, which is basically the first big line on this syringe. It's also known as 5 cc's. So that looks good. The first black line is covered by the very edge of the plunger. Then I'm going to put the syringe into the test tube. In order to expel the water, I need to let it, I can't push too hard, because if I push very hard, there's not going to be any space for the water to take up. So I'm going to hold it gently on top and I'm going to expel the water, but then I'm going to push it down onto the black rubber stopper, not so hard that I break the test tube, but just like firmly, so that the gas doesn't escape from the seal right in between the white and the black. So first I'm going to expel the 5 milliliters, and then I'm going to push this part down, not the plunger, just to keep a nice seal between the white and the black. And what you should see is that this plunger is going up as gas is produced from the reaction. So I'm trying to measure how much gas is being produced. Any new gas that's forming in the syringe could be considered to be the additional gas that was produced by the reaction. because remember that even though the tube looked partly empty, there was already air in the tube before we started. So this is the new gas, or the new air. You can flick it a little to make sure that it's fully reacted. I don't see the plunger moving anymore, so I'm going to take that off. And if we take a look, we have almost 20 milliliters of carbon dioxide gas. I would say this line here is the 15, and this line down here is the 20. So this looks like 19 milliliters of carbon dioxide gas. So that's what I'm going to record. For observations, you could also note if there's any powder remaining in the tube, it's still reacting after the syringe is removed. You might also notice how much liquid is in the tube. We added 5 milliliters of water. It looks like there's closer to 6 in here, but remember there was some powder in the bottom before we started. One of the products of this reaction is also water. And so the amount of water should increase slightly as the reaction takes place. And that's it. So you're going to try that, and then you're going to repeat it 3 more times with different combinations. You can repeat it more than 3 times if you need to. Just make sure that you're rinsing and drying the tubes in between the trials. You can set them on the wooden pegs here at the end of class so that they can continue to dry out.